Hi guys, it's Mr. Robeson here for section 5.1 in statistics. So we're starting our new section. We're going to start working with continuous random variables here. We're going to start off this section really just looking at something called a z-score. So the fact that it's continuous doesn't really mean much at this point, but in 5.2 it'll start to matter. So we're going to look at something called standardized scores or z-scored. We're going to look at interpreting them and how to work with them. Mostly it's just one formula, but let's look at what's the point of this. So how can we compare grades from two different classes? So we've got like a math class over here, and we've got an English class over here. So the students in a math class took a test. The mean score on the test was 80%, the standard deviation of 10 points. He scored 94 on the test. Good job, Keith. You got an A, right? In the English class, they also took a test. The mean score on that one was 85. The standard deviation there is 10. Keith scored a 95. So we could debate about which class Keith did better in, because like 94, 95, you'd think, oh, 95 is higher. He probably did better in English. But what class did he do relatively better in? So relative to the rest of his class, which one did he do better in? So the way we want to check that is we want to see, okay, how many points is Keith above the mean here? So we'd say 94 minus 80, and that would be 14 points. So he's 14 points above the mean here. Over in this class, it's 95 minus 85. So he's 10 points above the mean here. So then the question becomes, okay, well, 14 points is better than 10 points. So maybe he did better over here. But what we want to use as our measuring stick, though, is not just the number of points. Our measuring device is the standard deviation. So we're going to divide this difference by our standard deviation. And each one of them had a standard deviation of 10. So here we're getting 1.4. This one we're getting 1. So in math class, Keith got 1.4 standard deviations above the mean. I'm writing A, the mean. There we go. In English, Keith is 1 standard deviation above the mean. All right, so that's what we want to use to measure, and the one that does better here is the 1.4 standard deviations above the mean. So which class did you relatively do better in? Math, in this one. All right, so this is the idea we want to do, is we want to say, okay, what's the difference between our data value and the mean, and then divide by the standard deviation. Data value minus the mean divided by the standard deviation. And here it is as a formula. So here is our z-score formula. The other way to write this is just to say z equals the data minus the mean in parentheses, so you want to do that first, divided by the standard deviation. So that's it in words instead of symbols. All right, so what is a z-score, or what is a standardized score? It's the number of standard deviations a data value is from the mean. All right, what is the z-score used for? Well, oftentimes it's used for comparing things. From different distributions is what we just did. All right, we can do it, you can use it for a lot of other things too, but what we just used it for was comparing things from different distributions. All right, what does it mean if we have a positive z-score? Well, if the z is greater than 0, that means x minus the mean is greater than 0. And if we just add the mean over, that means x is greater than the mean. So that means the data value is above the mean. Or we could say greater than. So above or greater than. All right, so if it's negative, it's going to be exactly the opposite. So if z is less than 0, that means x minus the mean is less than 0, which means x is less than the mean if we just add the mean over. So that means the data value is below the mean. Or if you want to use more math terms, we could say that it is less than the mean. All right, so we can use positive and negative in order to compare z-scores to the mean. And we can also say it's the number of standard deviations a data value is from a mean. All right, so working with z-scores. So we're given a mean of 20. So mean 20. Standard deviation of 5. Standard deviation 5. A data value of 12. X 12. Find and interpret the z-score. All right. Well, z, the formula for z is x minus the mean divided by the standard deviation. So it'd be 12 minus 20 in parentheses, and then divided by 5. So that'd be negative 8 over 5, which is negative 1.6. All right, and you can type this whole thing in your calculator if you want. That's fine. All right, so and interpret. So it's negative. So z equals negative 1.6 means it's the data value is 1.6 standard deviations, and it's negative, so it'd be below the mean. All right, so the 1.6 is the number of standard deviations. The negative tells us that it's below or less than the mean. And then we can look back up here and see, oh yeah, 12, definitely less than 20. I mean, we know that right from the start. All right, the next one, we're given a mean of 50, a standard deviation of 8. So there's our sigma, 8, and a data value of 54. So x is 54. Find and interpret a z-score. So the z-score here is x is 54 minus the mean, so minus 50, divided by 8. So that's 4 over 8, which is 0.5. So z equals 0.5 means the data value is 0.5 or a half of a standard deviation. And it's positive, so this would be above the mean. All right, switch colors up here. All right, next one over here. So one pig, pig A, has a z-score of 1.2, and another pig, pig B, has a z-score of 1.6. How do the pigs compare? All right, I believe originally when I was writing this problem, I was talking about the weight of two pigs. But let's just say how do the two pigs compare? So pig B is farther above the mean than pig A, since 1.6 is greater than 1.2. All right, higher z-score, farther away from the mean when we're positive. If it's negative, we'll see what happens. Suppose two other pigs have the following z-scores. Pig C, negative 1.2, pig D, negative 1.6. Compare the weights of these pigs. So yeah, we were talking about weights when we were talking about the z-scores for these pigs. Probably should have had more information here. Tried to shorten the problem. That was my bad. So pig C is negative 1.2, pig D is negative 1.6. Compare the weights. So if you want to think about it as kind of like on a continuum, like say here's my z-axis, and here's 0 right in the middle. Negative 1.2 would be like down there, and that would be C. And then negative 1.6 would be farther down, that would be D. If you want to think about these other two pigs, pig A and pig B, so A was at 1.2 above, and B was at 1.6 above. All right, so if we're looking specifically at C and D, the one that's greater than, the one that's higher, is C. The one that weighs less here would be pig D. All right, so negative, bigger numbers negative or farther down negative means it's farther below the mean. So pig D weighs less than pig C. All right, it's farther down. All right, here we would say that pig B is farther above, so pig B weighs more than pig A. All right, and one more example here. So this is the kind of the tough one. Judy, who is a 25-year-old woman, has her bone density measured. Her results indicate a bone density of 948 grams per centimeter square and a standardized score, or z-score, of negative 1.45. The mean bone density of a 25-year-old woman is 956. Explain what this z-score means. So z equals negative 1.45 means Judy bone density is 1.45 standard deviations below the mean. All right, so her score is below average. Find the standard deviation. Well, here's the trick. We have z equals x minus the mean divided by the standard deviation. We know z, negative 1.45. We know x, we know her bone density, 948. We know the mean, 956. And we're just missing this guy down here. So what we do is we multiply this guy up, and then we divide this guy down. So we get that the bone density is, or the standard deviation is 948 minus 956 divided by negative 1.45. Right, this is a tougher question, I'll admit. All right, so it involves a little bit of algebra. I don't know how many of these type problems we'll have on assignments, but we still should be able to do it. So 948 minus 956 divided by this negative 1.45 gives us 5.5. So we get that our standard deviation is about 5.5. All right, part C. Use the mean and standard deviation to find the z-score for a woman with a bone density of 966. All right, so now we've got the standard deviation. We've got the, we've got the mean right here. So we can, and that's just going to be our x value. So the z-score here would be 966 minus the mean, 956, divided by that standard deviation we just found, 5.5. All right, and that does not look like a nice number, so let's just throw it in the calculator. So let's see, we've got parentheses, 966 minus 956, close parentheses, divided by 5.5. And we're getting, looks like about 1.8. All right, so there's the z-score for that. Explain the meaning of the z-score obtained in part C. So z equals 1.8 is 1.8 standard deviations above the mean. All right. So that's what that 1.8 means. It's positive, so it's above the mean, or greater than the mean. And that's how many standard deviations it is away from the mean. All right, so that's it for 5.1. So just working with z-scores, mostly just using the formula and writing those short little sentences.